We are looking at elementary statistics practice test 2 for module 2 chapter 4 probability. We're going to start with a few basic definitions, things you've seen. A simple event has a simple definition is an outcome or an event that cannot be further broken down into simpler components. A sample space is simply referring to all possible outcomes. A sample space is the set of all possible outcomes or simple events of a probability experiment. If two events are mutually exclusive, the probability that both will occur is 0. Disjoint or mutually exclusive. Events A and B are disjoint or mutually exclusive if they cannot occur at the same time. That is, disjoint events do not overlap. Probability of A intersection B is 0. And the way you write it, you can write it in this fashion or in this fashion or with the intersection symbol using the set theory. The probability of an event is always between 0 and 1, and it can include both 0 as well as 1. And the sum of the probabilities must be 1. What I want to explain about this, the only time it may not be 1 and extremely close to 1, it would be due to round-off error. Okay, so it may go to 0.9999, many nines, or 1.0000, many zeros and then 1. It could happen just because of the round-off error. That's why you want to keep up with the number of decimals. In fact, if you show fractions, that would be a precise answer in many cases. Sample space for tossing 5 coins would be 2 to the power of 5, which is 32. The way we calculated it is important. The number of outcomes per stage. That means there are 2 outcomes, heads as well as tails. And the number of stages, that means the number of coins, and that gives us 2 to the power of 5 or 32. If we were to write that, we would get H, H, H. Look at it. There are 5 H's, and at the end, okay, we have 5 T's. I'm not going to have enough space to show you the whole thing with a tree diagram, but if you were to get that started with a tree diagram, here's how it looks like for the first stage. And it's a good practice to be consistent by it's a tree diagram. So this is the first stage or the first toss. So you're going to keep the H at top and T at the bottom. So for the second stage, we do the same thing. We keep the H at top, T at the bottom. And now you're going to continue with that. You have 3 more stages. The number of combinations of n items selected, n at a time. Combination has the following formula. CNR or NCR. Let me show you 3 different methods. This is referring to a combination. This is referring to a combination. And this is where TI calculator uses the notation. The number first, combination, and then R. And the formula is n factorial over R factorial times n minus R factorial. And in a matter of comparison to the permutation, would be the permutation divided by R factorial. So let's go through the process. Remember, in this example, n as well as r are both n. Therefore, n factorial over n factorial times n minus n factorial. Now, this one is 0. Now, 0 factorial. 0 factorial is equal to 1. 0 factorial is equal to 1. So you want to change that to 0. NPR, it's n factorial over n minus r factorial. So for this question, where the number of permutation of n items selected 0 at a time is asked, that means the r value is 0, n factorial over n minus r factorial. Now, of course, what it means is that n times n minus 1 times n minus 2 all the way to n minus r plus 1. If you do that, you get n factorial over n factorial, which results in 1 again. Okay, a quiz consists of 3 true-false questions. How many possible keys do we have? And that's the same format. There are 2 outcomes, true or false, and we have 3 questions, 3 stages, 2 cubed or 8. If we were to write the sample space, this is what we get, again, starting with what we had. If you recall, okay, we can go with true and false here, true and false. So the first, the second, and now the third gives us 8 outcomes. And you want to be consistent. If the top is T, the bottom is F, and continue with the rest of them. It looks like this if you want to go that route. A pizza parlor offers 10 different toppings. We have 10 toppings and we're going to pick 4. I hope you realize order is not important, because that's the idea behind the combination. You have n different items, you're choosing R different items, and order is or is not important. If order is important, it becomes a permutation. In this case, order is not important. It doesn't matter which topic, okay, which topping you order first, therefore it becomes a combination, where n is a 10 and R is 4 class. So you plug in. We can change this to 6 factorial. Now, of course, you can use a calculator to come up with the answer. If you were to simplify it by hand, here's how it would work. You would keep the 6 factorial and change the 10 to, so this will be changed to 10 times 9, 8, 7, and now we stop at 6 factorial. Remember, 6 factorial means 6 all the way down to 1. The reason we stop, because we can cancel the 2. Again, if you're doing it by hand, and you got to change this to 4 times 3 times 2 times 1. I hope you realize that 4 times 2 equals 8. 9 and 3 cancel each other. We end up with 3 at top. Therefore, again, if we were to do it by hand, 10 times 3 times 7 is left in the numerator, 200. So it can be done by hand. How many 6-letter code words can we make? Of course, there are 26 letters in alphabet. So from 26, we want to pick 6. And we need to recognize this is a permutation, because order is important when you're making up a password, okay, a code. So it's a permutation of 26, choose 6. So that's a permutation formula. We are going to go with permutation 26, pick 6. And this one is, of course, 20 factorial. Notice if we want to go again by hand, 26 all the way to 21. The next one is 20 factorial, which cancels out the denominator. Let me just change the denominator to 20 factorial. In essence, you have a 20 factorial up here, 20 factorial down there, and they cancel each other. And that's the idea behind this. Of course, the number is huge, but the most important part is this, the process. A random sample of 100 people was asked if they were for or against the taxing on rich people. Of 60 males, 45 were in favor. Of all females, 22 were in favor. Write the contingency table and answer the following questions. If one person is selected at random, find the following probabilities. Now, I put these formulas up here for you. Those are conditional probability, because we are going to look into that in this question. So probability of A given B is known as a conditional probability. Is the probability of A intersection B over probability of B. Probability of B intersection B given A is probability of A intersection B over probability of A. It's important to mention a couple of things here before we move on. I'm going to write it and then I'm going to erase it because we need the space. If we were to calculate probability of A intersection B, it is the cross product. This is over 1. If we go this route, probability of A intersection B, and if we go this route, becomes probability of A given B times the probability of B. And if we go this route, it's probability of a B given A times the probability of A. You have all of these formulas in the formula sheet, so you don't have to memorize the formula, but it is important to understand the formula. The general formula for the intersection is given as such. If A and B are independent, then this changes to probability of A. If independent, then this changes to probability of A, and this changes to probability of B, and simply put, probability of A intersection B becomes probability of A times the probability of B. So that's important for everybody to know, because again, in this example, we counter that, and this independency plays a huge part in probability theory. So let's see how we move on. I'm going to leave this for a moment. I'm going to make up the table. I'll come back. I'm going to erase this and we continue. Let's come up with the contingency table, and I'm going to show you how to come up with that. It's very simple. So number one, we are looking at males and females, and then for and against. So for and against, whether you put it in the row or column, it doesn't matter, because you're either for or against, okay? Two different columns, males, females. And of course, we will have a total at the end. So the numbers in red are given. So take a look at the grand total, a random sample of 100. So you plug in 100 here. Okay, so that's the first thing. If they were for or against the tax increase of 60 males, so males total is 60. That's what it meant. 45 were in favor, so 45 for it. And by the way, the reason I'm putting M and F and T and A, because later on when we want to calculate, it's easier to go with just the initial, some sort of initial, make up, A, B, C, D, you name it. So far we have number 100, we have number 60, we have number 45 in red. What else do we have? When we continue of all females, that means we don't know this total size for females. 22 were in favor. Okay, so under the favor, in front of a female, we have 22, and we don't have the rest of it. So again, we have all those red ones. So how do you come up with 15? 60 minus 45. How do you come up with 67? 45 plus 22. Okay. How do you come up with 33? 100 minus 67. So if you come up with 33, you can come up with 15 plus 8. If you have 100 minus 60, you come up with 40. Then you come up with 18 and the rest of it. If you have those four numbers in red, you can come up with the rest of it because of this total. So the very first question is asking, this person favors the tax increase. Well, the total people, that would be the sample space. That is your denominator. And out of those, how many are in favor of the tax increase? So the formula would be P of T is N of T over N of S, where S represents the sample space. And so what do we have? 4, total of 67 people. So 67. You've done the table. You don't have to add them up anymore, but just I wanted to show you. Part B, female. Again, total is 100. How many? Total number of females? 40 over 100. Again, P of F is N of F over N of S. It's important to be able to write symbols so your reader can understand exactly what you're doing. Again, you can just go from the table and pick up the numbers. So if you didn't do that, 40 over 100 is fine. And it's a good practice to simplify the fraction. You want to come up with 40 over 100 to show your reader how you arrived at it step by step. And the rest, 2 over 5 is perfect, 0.4 is fine, and you're done. The next one, this person opposes the tax increase on rich people given that the person is a female. So you want to write the following conditional probability. Probability of A given F. So the person opposes. Okay, remember, opposing, we are showing it with A given F. And according to the formulas that we have here, probability of A intersection F over probability of F. And it becomes ultimately the N of A intersection F over N of F. The very first thing I want you to notice in the case of a conditional probability, the total sample size of 100 is no longer there. So one easy way for the sake of calculation, look at the denominator or look at what's after given. This symbol is given. F. How many in this category? F, we have a total of 40. So that is the new sample space. Your original sample space of 100 has shrunk to the sample space for the F group females, so your denominator is F, which is 40. Now, out of those 40, how many are against? So you are basically dealing with this row only. Out of 40, how many are against? 18. Okay, that's why we have the intersection of A and F. So 18 over 40. Of course, we do the simplification if we can, but 18 over 40 is more important than anything else for anyone to see what's going on. The next one, it says this person is a male given that he favors tax increase. Okay, so this is the next part. And if you were just to come up with the answer without writing all of this, I just want to make a point. Given, right after given, favors the tax increase. So for tax increase, 6. So you have no longer 100 as your sample space. It has gone down to 67. So take a look at the question. What comes after the given? That's your sample space now. 67 is the denominator, therefore. And how many are, this person is a male, how many are in this column? How many are males? 45 out of 67. So if you were just to do the numbers, but if you were to write it more properly, you would write probability of M given T. M stands for males and T stands for tax increase, is the probability of M intersection T over P of T by these formulas. And it changes to N. And the reason it does, because you divide the top and the bottom as this number over N of S. I want you to know that. And therefore, the answer is what I mentioned, 45 over 67. So you don't have to, this refers back to this one. And this 100, because total sample space of 100 drops and it becomes N, 45 over 60. This person is a female and favors the tax increase. First and foremost, the moment given is no longer there, you're back to square one and the total sample size of 100. It's important. The sample size only shrinks with the given, with the conditional probability, not otherwise. Therefore, this person is a female and favors tax increase. You are going to write the formula. Probability of F intersection T ultimately becomes N of F intersection T over N of S. And as I said, N of S is 100, F this row, and T this column. F, T, they come together, giving us number 20. The next one, this person opposes the tax increase on rich people, or, this is a or statement. This one is a or statement. This one was an and statement. This one a conditional probability. The or statement, the probability of A union B is probability of A plus probability of B minus the probability of A intersection B. In this case, the probability of A or F, probability of A union F, by that formula becomes probability of A plus probability of F minus the probability of A intersection F. So, in other words, if you look at the A, you have 33. If you look at the F, you have 40. But there is something in common between the two, and that has been accounted for 2 times. And that's really the idea, that you take off. This number 18 is part of this column. It is also a part of this row. That's why we take off their intersection. It becomes N of A plus N of F minus N of A intersection F over N of S. So as I mentioned, this column, total of 33. This row, total of 40. They have a common number 18. We're going to subtract because it's been accounted for 2 times. And that's your final answer. Are the events females? This is the event. And opposes tax increase. Are they independent? And the next part, are they mutually exclusive? Now, as far as the definition is concerned, for independency, it's simply put, the occurrence of one has no effect on the occurrence of the other. But just the definition is not good enough. You really want to go with the definition that comes from here when I did the cross product, because that is the proof with math. So that is the definition, which really sometimes is hard to understand, and I just mentioned. But the proof is, if you want to look at the 2 events, A and F, is the conditional probability equal to the marginal or simple probability? Probability of A given F, remember, given F. The moment you hear given F, you are in this, dealing with this row, total of 40. And A is against 18, so 18 over 40. Is that equal to probability of A? Well, A deals with the total size of 100 as the denominator, and A would have a total size of 33. These 2 numbers are the same. They are independent. They are not the same. They are dependent. And that's the idea. So that's a proof. By the way, you can look at the probability of F given A and see if it's equal to the probability of F. So one more time, you could look at probability of F given A and ask yourself, is that equal to the probability of F? That's another way. Are they mutually exclusive? Remember, the definition of a mutually exclusive is very simple. Do they have anything in common? And they do. Therefore, it's not. So probability of A intersection F. Look at the A column. Look at the F row. Because it's 18, 18 out of 100. If it is 0, they are mutually exclusive. Since it's not, they are not mutually exclusive. Find the probability of getting the outcome of tails and 2 when a coin is tossed and a die is rolled. And that's the same thing we were discussing, the concept of independency. The two are assumed to be independent. There's nothing that can say otherwise. Therefore, the probability of A intersection B is simply probability of A times the probability of B. So that would be 1/2 times 1/6. As you know, tails, heads, there are two outcomes, so 1/2. A regular die is 6-sided, so every number has the same probability of 1 out of 6. A box consists of 14 red and 36 blue. Okay, so right away we have total of 50. Okay, total of 50. We got to select 3 different markers. What is the probability that they are all red? And this is the idea of independency again. If they are independent, first of all, the probability of red would be 14 over 14 plus 36, just to give you an idea. So probability of red is n of r over n of s. And that becomes 14 over 14 plus 36. This is what's important. And of course, don't forget to simplify, but you've got to be able to see where the numbers are coming from. Part A, they are independent, just multiply them out. How many of them do we have? 3. This ultimately becomes the same for each case to the power of 3. Probability of all 3 being red, okay, that means their intersection. And because they are independent, just probability of R1 times R2 times R3, each one is 0.28. Do you have to write all of them like that? You don't have to. You get 0.021952 because we are simplifying 7 over 25, this whole thing to the power of 3. If it gets confusing, you can put a parenthesis, or 0.28. So 0.021952. As far as the number of decimals, you always carry as many as you need, okay? And if you are rounding, remember how the rounding takes place? You go to one more decimal and you make a decision. For example, if I wanted with 3 decimals, I look at 1, 2, 3. I look at the 4th one and I make a decision to change this 1 to 2. So you want to be very careful with your rounding, otherwise it will be wrong. Part B says, okay, we're going to do the same thing, but this time is without a replacement. The first one, and we are interested in the probability of R red. So probability of R3 given R1 intersection R2. This is R2, okay? And so what do we do here? In this case, understand that we have 14 red and 50 total. Now 14 over 50 for one of them. But the next one, everything goes down by 1. We no longer have 50, we have 49 total, and 14 goes down to 13. The next one, the total of 50 goes down to 49, goes down to 48. 14, the original size of red, goes to 13, goes to 12. So originally we have 14 reds, 50 total. Because it's without replacement, this 50 goes down to 49, this 14 goes to 13. The next one, 49 goes down to 48, 13 goes down to 12. This is the precise methodology, and you do it with a bunch of decimals and you come up with the answer. Now, it's important to see how this is done also with the tree diagram. You want to draw a tree diagram. By the way, the second method, probability of all 3 red would be n of all possible reds over n of s. We have 14, we want to choose 3, and it's a combination. Order is not important. And the total size, combination of 50, choose 3. We can choose from 50, we choose 3, but we want to choose red. From 14, we choose 3. That would be the numerator. That would be n of s to the numerator. You can try that and you see you come up with the same answer. In more complicated cases, this is the methodology to go. What I want you to pay attention to is the tree diagram. Here's what happens. You may be asked to write probabilities. So you would write 14 out of 50, and for blue would be 36 out of 50. Again, I don't want to simplify it. There is a reason. You see it in a moment. If they ask you for the numbers, and it may be easier to write the numbers, you just write 14 here and 36 here. When we go to the next stage, again, we are going to keep the same thing at top. It's red and blue. So if this is red, this is blue. Okay, so this is red, this is blue, and so on and so forth. Okay, so what happens now? 14 out of 50, 13 out of 49, or just 13, and this is 12 out of 48, or just 12. Now notice, for example, this branch is blue. Because we are here, and then here, and then here, no blue has been gone. So this one gives you still all 36 blue. So 36 out of 48. If we look at this one, it's 36 out of 49. Now, if we go to this branch, now this one, for the red, we have it all intact. All 14 are there, but the blue from 36 goes down to 35 in this branch. So first we have 36. Because this is blue, now it's 35. And you can figure out the last stage here, the blue from 36 to 35 to 34. But the red, it is still intact, total of 14. So that's how it works. Here's the next one. If the probability of winning is given as 5 over 12, what is the probability of losing? Whether odds against winning, so on and so forth. If the pair of odds is 6 to 1, how much profit do you make if you bet $10? All right, so complementary event, first and foremost, probability of A naught or A complement, or sometimes they call it A prime or A bar, is 1 minus probability of A. So if the probability of winning is given 5 over 12, then probability of losing would be 1 minus that. So 1 minus 5 over 12, common denominator is 12. 12 minus 5 is 7 over 12. Definition of a odds against. Odds against would be probability of a complement over the probability of an event. So the actual odds against event A. O represents the odds. Against is A complement. Is probability of A complement over the probability of A. It's important to see the formula. Again, it's given. You have it in your formulation. And we normally put them as A to B, okay, or A colon B, and they are in integer format. So with that being the case, we want the odds against winning. So we are going to write the formula. Odds against winning, that means odds for losing. That means probability of W naught, or probability of losing, over the probability of winning, according to this formula. So 7 over 12 over 5 over 12. I hope you realize the complex fraction, 12 cancel each other, 7 over 5. You can leave it like that, or you write it as 7 to 5. If the pair of odds is 6 to 1, how much profit do we make? Basically, you multiply this ratio. Let's say it's 6 to 2, that means 3, okay? 6 to this number, this is a fraction. Whatever this fraction is times 10. So let me explain a couple of things. First of all, the pair of odds against an event is net profit divided by the amount bet. So pair of odds is net profit over the amount bet. So net profit would be the product of these two. Okay, we are looking at the cross product. So pair of odds against an event is 6 to 1. The amount of bet is whatever in this case happened to be $10, and that means 60. Now, what I want to explain here is that it's important not to mix this up with when you play Lotto, for example. If you're playing something, let's say, like a blackjack, which normally pays 1 to 1 as far as the odds concerned, unless you get a blackjack. The amount of bet that you have, it's in front of you and it's not going to go away. If you win, they give you the same amount. So that's why the same amount is your net profit. Whereas when you buy a ticket, okay, if you bought it for $2, even if you win $100, $2 is gone. Number 16, a classical counting problem is to determine the number of different ways that the letters of personnel can be arranged. Find that number. So first, a quick reminder of permutations, and in this case, distinguishable permutation. when some letters are identical to others. Okay, the formula is n factorial over n1 factorial times n2 factorial, so on and so forth. The number of different permutations or their counts when n items are available and all n items are selected without replacement, but some of them are identical. So we are going to look at the number of letters and what's in common. And there are 9. Okay, we have total of 9. Then P, there is 1, E, there is 2, R equal, there's only 1, and so on and so forth. So you've got to count that. And now you're going to follow this and plug it in. So when you do that, the numerator is 9 factorial, and the denominator, you put all of them with the factor, or anything with 1, even if you don't, doesn't matter because that becomes 1. And so simplification will give us the following answer. Here's the next question. When 2 different people are randomly selected from those in your class, find the indicated probability. Assume birthdays occurs on the same day of the week with equal frequencies. What is the probability that 2 people are born on the same day of the week? The probability that 2 people are both born on Monday. And I hope you can see and distinguish between the two. In the first case, any day is fine for the first person. And then the second person must be born on the same day. Whereas here, we want one of them on Monday and the second one also on Monday, or any other day it works out the same. So that would be the difference between the two, in which case no particular day is specified for the first one. So the second person born on the same day as the first one is 1/7. And so basically that's the answer, because we want them to have the same birthday. And for the first one, it really doesn't matter. The first one has 7 choices out of how many? 7. But then it's the second one that doesn't have any choice. It has to be the same day as the first person. So the first person has a choice. That's 1 or 100% or 7/7. The second doesn't. Their product is 1/7. However, in this case, each one must be born on Monday, a specific day of the week. It's 1 out of 7. So each one has a probability of 1/7. And their product is 1/49. So it's important to distinguish among those, the two questions. How many different auto license plates are possible if we want to do the following? We want 2 letters followed by 4 numbers. The very first thing is that there are 6 spots. I want you to see that there are 6 spots. 2 letters follows by 4 numbers. So for example, here you would put what? Letter, so 26. The second one, I don't see any restriction. So again, I put 26. And then numbers. How many numbers? From 0 to 9, there are 10 digits. So I can put 10 here, no restrictions, and I keep on going. Therefore, it's 26 squared times 10 to the power of 4. I'm assuming everybody can do the math. I just want to show you how you arrive at the answer and the reason for that. And of course, you can put it into a calculator. Now, we're looking at the same 6 spots, 3 letters, no repeat. So that means if the first one is 26, the second one is 25, the next one is 24. It goes down because we can't repeat it. Followed by 3 numbers, no restriction, so each one can be 10. So you have 26, 25, 24, and the last 3, each one is 10, 10 cubed. Again, the process is important. 4 letters, no restriction, so all of them are 26. And then 2 numbers we can't repeat. So this one is 10, but this one goes down and it becomes 9. So the first 4, 26 to the power of 4. And the last 2, 10 and 9. Now we want 4 places. So the 6 spots is gone. We want 4 spots. So the very first thing, maybe you want to write 1, 2, 3, 4 spots. Each character is either a letter or a number. Well, we have 26 plus 10, 36 characters. And each one can go here. There is no restrictions. So there are 36 characters, 36, 36. So it's 36 to the power of 4. By the way, when it comes to combination, factorial, permutation, you can use a TI calculator. I have the command here just to let you know, it can make your life easy. But it is important to understand the process and what happens. So we have in a first grade school class, we have 10 girls and 8 boys. In how many ways can we choose the following? So let's go with the first one. The students finish first, second, and third in a foot race. So no ties. Well, you have total of 10 plus 8, 18 students. Order matters. You're picking how many? First, second, third. You're picking 3. It's a permutation of 18. Pick 3. So you can go with the permutation formula. You can say 18, 17, 16. However, either way gives you the same answer. Now, in the second case, the girls finish first and second in a geography contest. Now, we are dealing with how many? Total of 10 now. And how many places? 2 places, and order is important. Okay, so again, it's a permutation. 10, choose 2. Now, 3 boys we selected for lunch. Out of 8, we want to pick 3. Order is not important. Combination. So combination of 8, pick 3. Again, I'm hoping everybody can see the concept as to why it's a combination, why it's a permutation. The rest is very simple. 6 students be selected for a team, any team, hockey team. Okay. So we have what? Total of 10 plus 8, 18, and we want to use 6. That means order is not important. That's a combination. 5 students. How are we going to select them? 3 boys, so that's 1 spot, and then 2 girls. Okay, 3 boys out of 8. There is no restriction. Okay, order is not important. So combination of 8, choose 3. Done. 2 girls out of 10, 2. It's a combination again because order is not important. And then you, by the way, for this one, I'm showing you if you use a TI calculator, you put 18 first, then NCR, then number 6, and it gives you the same answer. Okay, this is in case as an example. Now, order is not important. Combination of 8, choose 3 times combination of 10, choose 2. So in essence, this one uses a combination here, this one uses a combination here. Their product is the answer. And then finally, 4 girls be selected for a field trip. Out of how many? 10. We want to choose 4. Nothing is specified. Order is not important. Therefore, it's a combination. So combination of 10, choose 4.